Hello everyone, True Zero Emissions here. Okay, so we're going to wrap another wire around. So this is my Don Smith rotating separator coil research and experimentation. And I'm going to wrap another wire around this magnet. I think this is a 3" by 6". Let's see, 3 by 6 by 1" approximately. So I didn't see anything happen here when I moved the magnetic field past this. I was spinning this past it, see? I was spinning this. Those are neodymium magnets. I thought I would try the 90-degree angle, right? Is that 90 degrees? This is probably 90 degrees. I don't know if I tried that. I should probably try it. Let's go ahead and try it. I don't think I tried that angle. And is this AC? I think it's AC. I'll put it at 2 volts just to see if anything's happening. Oh, I think I tried it on this side. It's similar. That's the same thing, I think. Okay, I don't see anything at all. Nope. Try DC. Yeah, I don't see anything at all. Okay, so what I thought I would try is winding another coil. I can't think of I cannot remember the gentleman's name. There was a gentleman that had magnets like these. He would place 2 of them with a space between. He would wrap wire this way. Okay, so imagine a coil of wire like this, right? But it's in between the 2 sets of magnets. And then he'd wrap another one like this. So this one would go this way. He would put a little bit of power in one of the coils. And then the other coil, I think, was... I don't know how much energy was coming out of it, but I feel like more energy was coming out of the other coil that was at a different angle. And then also when he put power into it, when he turned up the power going into it, the whole magnet would levitate and literally just float around the room. I will check my notes to see if I can find the name of the gentleman that was doing those experiments. I feel like I almost can remember, but I cannot remember. I'm going to go ahead and use this copper wire. I don't even know if this can be used for this. It's called Super Slick Encore wire. I was literally driving down the road one day and I saw this sitting on the street. I couldn't believe, look how big this is. It was just sitting there on the street. 2 big rolls of wire. I couldn't believe it. I'm like, how did someone not pick this up? And I looked around, I talked to people, no one said they knew anything about it. They said, I don't know. No one knew what it was doing there. Solid manufactured in 2019. Encore wire. I don't know. I mean, I'm just going to see if it does anything. If it doesn't, I can always try. If it doesn't do anything, I can always try a different wire. This wire might just be much, much too thick. I mean, it's very, very thick wire. This is very, very thick wire. I have my safety glasses on. This is found wire. Isn't that funny? Found wire. Excuse me. So how is what I'm doing right now? I don't know if the gentleman's name was Sweeney. I want to say Sweeney, but I'm probably wrong. Sweeny, Sweeney. That could be wrong though. I don't think it's Sweetser. Sweeney, Sweetser, I don't know. Sweeney or Sweetser. A gentleman that was doing experimentation. His teacher was a famous person that was very, very knowledgeable. So the person I'm speaking of learned from someone that was very advanced. Okay, let's see. Let's go ahead and I'm going to zip tie this in place. I'll zip tie this in place so it stays. Tighten that down. And then I'm going to go ahead and wrap this. I'll try to keep it in camera for you. So I'm not doing exactly what they did, but what this person I'm speaking of did, but I am just wrapping a magnet in a different angle. See, these go this way, and then these other ones will go this way. And then what I'm planning to do is put some power, or I have to probably put another zip tie here to hold this in place as well on this side. Otherwise it's gonna come off. Oh, I figured out why my throat is so dry inside when I'm talking in the videos. It's because I always have the air conditioner on, and air conditioner dries the air out. Isn't that interesting? Intuitively, I would have thought that an air conditioner makes the air more moist, but it actually does the opposite. I think it dries the air out. Excuse me. So I'm going to go ahead and... So I need to probably get a humidifier. That's probably what I need. So I'm going to go ahead and wrap this. And I have no plans to unwrap this magnet after I wrap it. But I could add more wire on top of it at later dates. I think this is the kind of wire that would be used like in a house. I don't know though. It's very thick and it's very hard to bend. Is it pure copper? I don't actually know. I don't know if it's pure copper. I don't know what it is. I have some stranded wire that I use for like electrical, when I'm doing things with electrics. That bends a lot easier, but it's a mixture also of different metals, right? I don't think it's pure copper. What I do not have is magnet wire, and I don't know if that's necessary or not. That's something else that could be considered if needed. Where I do have what I think is considered magnet wire is where all the alternators I have, and then the motors I have, I think those all have the really high quality, what's called magnet wire. Bend this thing. Oh, I don't want that damaging scratching the floor. I feel like the gentleman's name was Sweeney, S-W-E-E-N-Y. That might have been his name. But there's a name for his project. I don't know what that's called. if it's the Sweeney generator, or I don't know, Sweeney anti-gravity magnets that would pull it up. To pull up the patents or the experimentation or any literature or research on it. Anything other than something not being able to be done, because all that stuff is just irrelevant, because we're not trying to learn, we're not trying to read that we can't do things. We're trying to think about how we can do things, right? We already know that the greatest minds on the planet have said all things, scientifically speaking, are inevitable. So anyone that wants to say a water-powered car can't work, well, talk to Toyota. They're making a water-powered car. Talk to anybody that buys gasoline. That's mostly water. Gasoline's, if there's hydrogen in there and there's oxygen, that's the makeup of water, right? So I'm going to go ahead and wrap this thicker. I don't know if I should do that or not, but I might as well. Why not? That way one of these will be thicker, more wire than the other one, right? This is a little bit messy. It's not perfect. So when I think of two separate wires, it makes me think of a transformer, right? But right now what we're doing that's different is we're wrapping a magnet, and transformers are not using magnets. They're using a metal that a magnet can stick to, called a ferrous metal, but not a magnet in itself. And then a separate question is, do circuits use magnets presently to smooth out current, voltage, to act as a filter? I don't know. So this is getting really thick now. I'm not counting this, I'm just winding it. I haven't counted what's here. I could use the whole reel though, the whole thing. I'll just see what it does. So thicker wire, if I recall correctly, gives more amperage, right? Gives more current. Well, this is this is really thick. This is really a lot of amps. But what's our voltage? Okay, so let me see. Oh, that's that one. Oh, okay. So this one and this one are the same wire. I think that's enough for now. I don't know where my cutters are to cut the wire. My wire cutters. Found them. All my tools are sticking to this. Okay, let's strip the wire if I can. That'll let me access the wire, the copper part of the wire. Okay, I'm going to put more zip ties here. Oops. I broke the zip tie, but it's from tightening it too much. It didn't break the part that was tight. It broke the extra part that I was cutting off, that's okay. Okay, I'll put a zip tie in the middle. The zip tie is just long enough to reach around this. Well, actually, I don't know if it's long enough for this one. Oh, it just reaches. Just reaches. Just barely. Okay, that's very tight on there. I was reading that people were wrapping coils very tight because they want to get have the copper, the most copper close to the metal as possible, and to have it as close as possible. And I didn't know that. I didn't know that's why people were wrapping them tight. I didn't know that's what was making the difference. And I don't know if tension on the wire makes a difference, right? Like pulling a guitar string really tight, if that makes it, if there's something there. That's okay. Here's our magnet wrapped in wire, and I guess I'm going to kind of treat it like a transformer, but I still want to see what happens when oh, the charger's done. Let me turn the Wolf King GTR is fully charged. Okay, the Wolf King GTR is fully charged. It's the scooter. It's fully charged. Okay, I need to get some wires. Let's see what I can do here. I'm going to bring the longer wires over, since we're going to be working on the floor. Okay, so I'm going to use, let's see how we're going to do this. Let me think about this now. So do I want to put, I think there's more wire this way. So on this magnet, one side is north and the other side is south. And that goes all the way up to the halfway point there, right? So in both of these wires, half of the wire is on north and half of the wire is on south. But as you can see, they're at an angle to one another, at a 90, I think that's a 90, yeah, that's a 90-degree angle. I always hear 90 degree angle, 90 degree angle. I mean, I don't know what that is. I don't know why 90 degrees is so, it's always coming up. But why not? Let's see what happens. Okay, so this wire and this wire are for this one, and then this wire and this wire is for the other one, this one. Okay, so I'm going to put power in the less wire. I'm going to run this battery here. I got a battery, 12-volt battery. Is going to power my pulse width modulator. Now I would like to put high power into this, and I do have a big battery as an 84-volt battery for experimenting, but I'm not going to start with that. And I also don't want to burn out my pulse width modulator. Robert said I need a 555 timer to power the magnet. That's what he was suggesting. Okay, power and motor. So I'm going to go power here. Apologies that you cannot see. Maybe I can turn this so you can see what I'm doing. There you go. I'll just keep turning the camera so you can see what I'm doing here. So right now I'm just trying to be careful not to let things arc. It's really easy to... Okay, I don't know why there's no light on this. That's concerning to me. This usually lights up. Did I hook it up backwards? Did I burn it out? Usually a red light comes on this. Okay, so this is power. Well, I'll hook up the output and see, and just take one step at a time. Maybe the light's not coming on because there's no load on it. Let's see. Unless I completely burned it out, or unless my battery's dead. Let me check the battery real quick. Check the battery real quick. Okay, we're going to check the battery, which is DC. I have to be careful not to let the wires cross because they will arc. There's 13 volts in that battery. Okay, there's 13 volts in the battery. Now I'll hook up the output of the pulse width modulator. This wire got super hot. I can see it's like melted. I'll make sure the power's off. I'll connect the output to one side of the coil. This is just an experiment. I don't know. This is probably bad for the pulse width modulator. I never recommend doing what I'm doing. I'm just doing an experiment. Just want to see what it does. So this side usually goes to a motor right here. I'm going to a magnet. Okay, now I'm going to go connect the voltmeter to, I'll leave it on AC. I'll put it on 1,000 volts just to be safe. That way it doesn't cause burn out my meter, just in case the voltage jumps really high. So I'm going to hook the meter up to each side of this. That may have to go into a full wave bridge rectifier though, now that I'm thinking about it. Well, let's just see what it does on AC, on the AC setting. It's not doing anything. This isn't turning on though, and that doesn't have an on and off switch. Robert did say my capacitors were burned out in there. Oh, you could see them. Yeah, I could see that they exploded. But it was still working before, and now it's not. Okay, let's disconnect the output. I think I have another pulse width modulator, but if I burned this one out the last time I used it, I don't really want to damage another pulse width modulator, especially if it's not the right thing to use for what I'm doing. So these capacitors are exploded in there, Robert said. I could see that. I can see that they're pushed up. Let's see if I can get this to focus. I don't know if you can see those capacitors kind of pushing against the top of this. I've never seen this not turn on, so I'm surprised the light didn't come on. Last time I used it, it was working. What is this? Is this a reset or on and off switch? Take my glove off and look, see if I can zoom in. read this here. See what that says. Run and stop. Okay, that does look like an on and off switch to me. So it could be that the capacitors are completely burned out, or that it blew a fuse. Okay, that's not going to work now for a test. Let me think about this. What do I have that I can power this coil with? I just will disconnect this because this is dangerous to have wires on the battery. Okay, let's see what I can do here. We have a meter there. We have these wires going to these two. That and that one. Let me see what happens if I just touch these on here. Okay. Oops. I was thinking of wrapping this bar, because this bar sticks to this really strongly. Wrapping this with wire. So I was thinking of wrapping this bar here, which sticks to magnets, with wire, and then seeing if I'm getting any voltage out of it. Well, since we're here, let's try connecting my motor here. Let me cut these wires out. Cut these. Oops, that almost fell. I'm really glad that didn't fall. Okay, so I have 3 wires here. I think I can go further. I don't know if this is showing here. Yeah, try to show you what I'm doing here. I think I'll send this into a full wave bridge rectifier, because what can I do with 3 wires otherwise, right? I can't even connect that to AC, right? Because it's, or could I? I don't know. Let's see what's happening here. Those look like they could be plugs right there. Let's keep going in and see what we see here. I don't know if this is focused, but I hope it is. I just touched the phone with my glove to make it focus, but I don't know if the phone responded to my glove, because I don't know if these gloves have the where this phone responds to the touching the phone. I don't know if these gloves do that. Okay, well that's good. I'm just going to strip these wires. I'll just strip the coating off here. And then we'll proceed. Okay. Okay, let's proceed. Turn these. So I'm going to connect these to my rectifier, which will change it into DC. I have 2 different kinds of, these are both purchased on Amazon, I think. I don't know if those are showing up at all though. See if the phone will focus here. If I touch the screen a little bit. So these have 3 input and then 2 outputs. So there's a plus and a minus. Perfect for this kind of situation. And I'll use the shorter wires since everything's close together. So for the going from the motor generator to the bridge rectifier, which converts the AC into DC. I'll just use these wires, the white wires, because this is just AC, right? I think each of these is probably 3 phases, right? 3 separate. I'm not exactly sure what it looks like in there. Inside the alternator, inside the motor. I don't know exactly what it looks like. Okay, this one's kind of stuck. There it goes. I want to push the cover down on that. Okay, so now we have a plus and a minus. I'm going to hook that up to the meter. Let's see. Okay. I just want to see what this does, what the meter says when I connect, when I turn this motor. So this is DC now, the straight line. I'll put it on 20, even though we might only get a volt or something. Oh, let's make sure this is in focus. There we go. So I'm going to turn this by hand and try not to shock myself. So I'm turning it by hand. That's, oh, my polarity's backwards. That's these 2. because the meter was showing a negative. Now it should show a positive. Look at that, I'm turning this at this speed. I'm getting 1 volt. 1 volt, that's it. I mean, I'm kind of amazed by that, because I'm like, just 1 volt, that's all these magnets? But if I spin this fast, the voltage would go up, see? Watch. I'm up to 3 volts, 2 or 3 volts, right? But how nice would it be if we just turned it real slow and it had a lot more power? Let's try, just curious, now that we have a number, right? Now that we have kind of a manual generator. By the way, that bridge rectifier tip does knock the voltage down as well. I'm going to put the bridge rectifier into this magnet that we just wrapped with wire. I'm going to connect it to that magnet. So let's do that. I'm going to have that power going to the magnet now. So we got 1 volt going into the magnet, right? Around the wires that are connected to the magnet. Okay, so where was that? Oh, I think it was here. Oh, this is the... Okay, we could try that. I'll try putting it on the outside one. And then, so on the outside wire is where the power is going into. The other wires, where are they going? I have to find where I have those wires going to. What in the world? Oh, everything's just sticking to this now. Okay. So the output, okay, so the other wires, the other set of wires, this is, I'm treating this like a transformer right now, but with these really thick wires, right? So I don't even know if anything's going to happen. Because usually in a transformer, we use very thin wire. Our transformers usually have thin wire. Let's see what happens, if anything happens here. I'm going to leave it on DC. Let's see if you could see that display there. Yeah. So I'm turning the generator. We were getting 1 volt out. That's now going into these wires here. Which ones is it going to? These wires, the outside wires. The inner wires are going to the meter. I'm just curious if it'll do anything. Or if it'll show anything, right? Is it showing anything? I feel like I'd like really, really high frequency. I feel a load. That's because it's shorted out on that coil. I could feel it though. I put it over to AC. Okay, that didn't do anything. What if I connect... Let me think about this. Okay, what if we take the DC out and I connect 2 of these wires? Connect 2 of the wires to the same wires I had the DC connected to. Oh yeah, that really resists. Now there's a lot of resistance, but it's still not doing anything with the meter, right? That's funny, that's a lot stronger resistance compared to going through the full wave bridge rectifier. Well, we did a couple experiments tonight. I think that's enough for now. And This is just the beginning. It's just the beginning. What's the next step? I mean, I feel tempted to just take all my lawnmower motors and have them all connected in series to one another, so the voltage is really high, and then connect those somehow into a trailer that I pull with the scooter and see if I can charge batteries. So the trailer, if I have a trailer that I'm pulling, right? If I'm pulling a trailer on the scooter, inside the trailer, the wheels are connected through gears to all the alternators somehow, right? So that when I'm pulling the scooter, all the alternators are spinning and they're wired in series to make high voltage, right? And then have that charging a separate battery, separate from the one that's in the scooter. And then when the scooter battery is depleted, I can connect the battery that I charged up with the alternators that are all wired in series, but just make sure not to overcharge the battery, right? So let the voltage come up on the battery, and once it's full, disconnect it. I would manually do that. I'd have to watch the voltage closely on a monitor. But that's supposed to be the easiest way to charge a battery, is the alternators wired in series. And I haven't tried it yet, though. I want to try that. Okay, everyone, True Zero Emission signing off. Thank you for watching the video, and we'll see you in the next one. Okay, bye.